Hello everyone, welcome back to the AI Academy's course on AI in Marketing. In today's lecture we will discuss about the Ideas Framework in Marketing, a robust structure that outlines the 5 essential elements of today's technology landscape. So, we will explore the Ideas Framework, and gain a thorough understanding of the 5 pivotal elements shaping technological integration in marketing strategies. We will also examine the intelligence and data landscape, where we will focus on the components of intelligence and data within the Ideas Framework, emphasizing how they influence marketing decisions and strategy formulation. Next, we will analyze human and machine intelligence, wherein we discuss and differentiate the various dimensions and capabilities of human and machine intelligence, providing a clear perspective on their unique and complementary roles. We will also investigate the trade-offs and study the decision-making process involved in leveraging human versus machine intelligence to address complex marketing and business challenges. Then we will identify system shortcomings, acknowledge and understand the limitations and potential pitfalls of intelligent systems when faced with different problem scenarios. And in the last, we will uncover foundation of data building blocks, where we will explore the critical components necessary for constructing a modern data foundation that supports advanced marketing strategies. So, consider a scenario where a company uses the Ideas Framework to optimize its digital marketing campaigns. By analyzing the intelligence and data landscape, the company can employ machine learning models to predict customer behaviors and preferences with high accuracy. However, human intelligence remains crucial for interpreting nuanced social trends and making strategic adjustments that the model might not capture. This module will help learners understand how to balance these intelligences and recognize the limitations of relying solely on automated systems, such as in cases where creative problem-solving is necessary. Coming to the Ideas Framework, it constitutes of 5 elements of the technology landscape, and they are: the first component is intelligence, which refers to the application of both human and machine intelligence to analyze data, recognize patterns, and generate insights that guide strategic marketing decisions. This element empowers businesses to uncover new opportunities, predict customer behaviors, and personalize marketing campaigns. The second component is data, which involves the collection, management, and analysis of large datasets. Properly harnessed, data enables companies to identify trends, understand customer needs, and measure campaign effectiveness, driving more accurate and profitable decision-making. The third component is the expertise, which represents the skills and knowledge required to apply intelligence and data effectively. It includes data scientists, marketers, and technologists who can design and implement AI solutions that align with business objectives. And the fourth component is architecture, which refers to the technological infrastructure necessary to support AI and data initiatives. This includes cloud computing platforms, data storage systems, and scalable software frameworks, ensuring seamless data processing and integration. And the last and fifth one is the strategy, which involves aligning AI and data initiatives with broader business goals. A strong strategy helps companies prioritize investments in technology and allocate resources effectively to create an organized plan for sustainable growth. These 5 elements form the foundation of the Ideas Framework, enabling business leaders to explore value creation opportunities in the areas like: in procurement management, by using predictive analytics to forecast supply chain trends and reduce costs to streamline the procurement. Accelerate technology innovation by integrating AI tools and fostering collaboration between tech and business teams. Enhance HR strategies through AI-driven talent acquisition, retention analytics, and employee performance predictions. Develop a scalable, secure, and efficient infrastructure that aligns with AI-driven strategies, ensuring seamless data flow and process automation. Together, the elements of the Ideas Framework transform traditional business operations, providing innovative ways to create and distribute value while revolutionizing how leaders approach management and strategic planning. Next, we will discuss about the intelligence component of Ideas Framework. The intelligence component focuses on handling the situation where we can avoid simply adopting the technology without a clear purpose, which often fails to provide meaningful value to companies. Current technologies that heavily rely on deep learning lack a nuanced understanding of fundamental concepts like connectedness, space, and time. Companies are now focusing on developing adaptable applications and machines that mimic the problem-solving approaches of humans. Some of the example applications are the robotics in warehousing, where modern robots can navigate warehouse environments and manipulate items without explicit instructions, demonstrating adaptability. The emotional AI, which was initially developed to help autistic children express emotions, this technology has evolved into onboard AI for vehicles, potentially saving lives by detecting driver fatigue and preventing accidents. By blending cognitive characteristics like awareness and adaptability, these technologies aim to offer intelligent solutions to various commercial and social challenges. When we talk about human versus machine intelligence, the human supremacy, as we know, even the youngest humans effortlessly learn and comprehend the world. They can intuitively understand others' intentions and possess an early sense of physics, like expecting objects to follow smooth paths and understanding gravity. This inborn cognitive ability allows humans to adapt to new situations with remarkable flexibility. And when it comes to machine supremacy, AI excels at tasks involving pattern recognition in extensive data sets and outperforms humans in complex games like chess and Go. The machine intelligence can efficiently automate manufacturing processes, analyze environmental data for agriculture, detect financial fraud, and predict consumer preferences for personalized marketing. Next comes the middle ground, where automating many tasks surpasses human capabilities and traditional programming logic. And AI enables humans and machines to complement one another, turning mechanical processes into more adaptive, human-centered activities. And then comes the human-like machine intelligence. A 2022 Accenture report highlighted that over 75% of major companies have deep learning initiatives underway. The deep learning, a machine learning subset, leverages neural networks to solve complex problems. However, its data-intensive nature presents challenges in capacity, affordability, and sustainability. The new research focuses on making machine intelligence more human-like, emphasizing efficient learning models that don't require exhaustive training like autonomous vehicles but can adapt more like infants. The implications for senior leaders are that they must understand the limitations of current AI approaches and navigate the delicate balance between human and machine intelligence. This ensures organizations are well-positioned to adapt to emerging technologies that blur the line between artificial and human intelligence. So, the trouble with intelligence is that the present-day AI, particularly deep learning-based systems, faces several limitations that necessitate a more human-like approach to machine intelligence. While deep learning excels in narrowly defined problems, it falls short as a foundation for achieving broader, general intelligence. Let us now explore the key issues with current AI. The limited intelligence like image recognition issues. Despite recent successes in image recognition, AI can still be easily confused. For instance, subtle changes in images can lead to significant classification errors, which can have fatal consequences in applications like autonomous vehicles or delivery drones. The black box problem, for example, the opaque decision-making. Like today, many AI systems are used for critical decisions, such as loan approval, hiring, parole decisions, and advertising. However, deep learning algorithms are often opaque and difficult to interpret due to the vast number of parameters and interconnected layers. And the consequences of opaqueness is like when these systems reach inaccurate conclusions, they can have disastrous outcomes, like discrimination in lending and hiring or placing ads next to extremist content online. And we also see the lack of fundamental knowledge frameworks in the current AI, like causation versus correlation, where deep learning algorithms excel at identifying correlations, like linking symptoms to specific diseases. However, they lack the ability to understand causation, a fundamental aspect of common sense. The current AI also lacks the inability to generalize, where without understanding causal relationships, machines struggle to transfer knowledge between tasks and require retraining for each new task. Understanding causality would enable AI systems to apply existing knowledge to new domains. To overcome these challenges, there is a need to shift towards more adaptable, transparent, and causally aware AI models. This shift will help align machine intelligence with human-like thinking, improving decision-making, interpretability, and generalization across various tasks. Now we will discuss about human and AI augmentation. The collaboration between humans and AI has unlocked a new frontier of productivity and innovation. By working together efficiently, humans and machines have created opportunities for new, high-value jobs that blend human expertise with machine capabilities. For example, the case of Obeda, a German electronics wholesaler, where the role of intelligence was to train the robot pickers. At Obeda, which relies on Austrian logistics company NAP, the human workers train robot pickers to handle various items. By exposing the robots to different objects, workers test their adaptability and response. They also implemented the learning from mistakes method. When a robot struggles, it updates its understanding of the object and tries new approaches. Success is reinforced through reward signals programmed by humans. How supervised learning helped Obeda? So, for the sets of SKUs that differ significantly, NAP's team uses supervised learning to collect and label new training data, similar to deep learning techniques. This helped the robot pickers to gradually develop general-purpose abilities like 3D perception and understanding how to manipulate different objects. They handle electronics carefully, distinguishing between fragile light bulbs and sturdier stoves. And the implications of using smart robots were the increased reliability. NAP's robot pickers, now powered by covariant technology, can handle around 95% of objects reliably, a significant improvement over the previous 15% reliability rate. Faster speed. Robots are faster than human workers, picking about 600 objects per hour compared to humans, who average around 450. And the human workers are retrained to understand more about robotics and computer systems, enhancing their skills and adapting to the evolving job market. This example illustrates the power of human-AI collaboration. By leveraging each other's strengths, humans and machines achieve higher productivity, greater accuracy, and new opportunities for skill development, underscoring the transformative potential of intelligent systems in modern workplaces. Let us now discuss about the future of intelligence. In the formative work of AI, building machines that learn and think like humans, the authors emphasize that natural intelligence remains the best model for understanding and advancing artificial intelligence. They assert, as long as natural intelligence remains the best example of intelligence, we believe that the project of reverse engineering the human solutions to difficult computational problems will continue to inform and advance AI. For business leaders, the critical question becomes which human-like cognitive abilities are most relevant for capturing business value and delivering exceptional customer experiences. When it comes to generalization in real-world settings, the practitioners are not waiting for theoretical consensus on whether deep learning or an ideal version of artificial general intelligence will pave the way for human-like intelligence. Instead, they're actively drawing from all branches of AI to unlock new machine capabilities and enhance performance in diverse settings. The Covariant is working on expanding its brain, an AI system designed to power robots across various industries like manufacturing, agriculture, hospitality, commercial kitchens, and, eventually, home applications. This aims to enable robots to adapt to varied environments and tasks, demonstrating cognitive abilities parallel to human generalization skills. For example, the smart robots used by Obeda, a German electronics wholesaler, exemplify how advanced AI can be applied to real-world challenges. These robots learn and adapt in real time through human guidance, enhancing their picking capabilities. The future of intelligence lies in combining human cognitive abilities with the computational power of AI to achieve generalization across varied, real-world settings. By leveraging interdisciplinary advancements, AI will increasingly become capable of learning, adapting, and making decisions in environments traditionally dominated by humans. Senior leaders must identify which cognitive skills will offer the most significant value to their business strategies and customer satisfaction. So, it looks like a survival of the fittest algorithm. For example, the e-commerce retailers like Zappos often struggle with providing relevant search results due to the multiple interpretations a search query can have. For instance, when a customer searches for a specific type of dress shoe but ends up seeing dresses instead, they may leave the site out of frustration and choose a competitor. This challenge emphasizes the critical need for search engines that can accurately interpret user intent and deliver relevant results. And to address this problem, Zappos employs a survival of the fittest approach where different algorithms compete against one another in a digital game of survivor. Their approach involves relevance test, which simulates real user behavior, and algorithms that deliver accurate search results are rewarded by passing their successful traits to the next generation of algorithms. Live testing of the top-performing algorithm is deployed on the website until a more accurate, fitter version outperforms it, continually enhancing the search engine's performance. Next, how can we make better bots, as humans can sort through probabilities and act based on the most likely outcomes, even with minimal prior experience? Machines are now learning to replicate this reasoning using Gaussian processes. These probabilistic models manage uncertainty by creating predictions that consider potential variabilities. They can function effectively even when there is little prior data available. And in the last, they learn from experience to improve their accuracy over time through continual learning from user behavior. This evolutionary approach ensures that search algorithms are continuously optimized, enhancing user experience by delivering more relevant results. The use of Gaussian processes further supports machines in managing uncertainty, mimicking human-like reasoning to deliver accurate predictions even with limited data. These advances in search technology offer a competitive edge in customer retention and satisfaction, crucial for businesses operating in fast-moving digital marketplaces. Moving on to closing in on causation, the AI systems excel at identifying correlations and making predictions based on those patterns. This strength has been pivotal for companies like GNS Healthcare, a precision medicine firm in Cambridge, Massachusetts, which collaborates with major pharmaceutical companies. The GNS Healthcare's causal algorithms enable pharmaceutical companies to understand which patients respond to specific drugs and, crucially, why. Their software uses Bayesian techniques to transform data into causal models, identifying which variables are most influential in driving outcomes within a dataset. So, confronting on time and space, about optimized video recognition, research from the MIT IBM Watson AI Lab has introduced a new technique that significantly improves the training of video recognition systems. Their approach is not only highly accurate but also reduces computational costs. And by leveraging this technique, researchers have achieved training speeds for video recognition models 3 times faster than previous methods. This accelerated training is crucial for autonomous vehicles, enabling them to interpret and react to visual data and anticipate future events in their surroundings. And what are the implications of faster training? It enables autonomous vehicles to process and understand visual data efficiently, leading to safer and more accurate real-time decision-making. And the retailers can also benefit from this advanced video recognition technology. It can enhance store surveillance, analyze customer behavior, optimize inventory management, and improve targeted marketing strategies by understanding customer preferences in real time. By advancing AI's ability to pinpoint causation and efficiently process visual information over time and space, these breakthroughs significantly extend the potential applications of intelligent systems. Businesses across sectors like healthcare, retail, and transportation can harness these technologies to gain deeper insights, improve decision-making, and enhance user experiences. If we talk about common sense in AI, the current challenges are that modern AI systems struggle to answer simple, common-sense questions like, if I put my socks in a drawer, will they still be there tomorrow, or how can you tell if a milk carton is full? This gap in reasoning highlights the limitations of AI in understanding everyday concepts. And the progress in research in this area are the Allen Institute for Artificial Intelligence is developing a portfolio of tasks that will help set benchmarks for common sense in AI, providing measurable progress indicators. Also, the Defense Advanced Research Projects Agency is investing $2 billion in AI research, particularly in the Machine Common Sense program. This initiative aims to develop models that mimic human cognition, focusing on understanding like objects, intuitive physics, how objects interact physically. Places, spatial navigation, navigating spaces with situational awareness. Agents, intentional actors, recognizing actions and intentions. And regarding disambiguating natural language, the researchers from Microsoft and McGill University have developed a system that effectively untangles language ambiguities, solving a challenge that requires multiple forms of inference and knowledge. The goal is to provide the right answers with rationales, reducing user frustration in chatbots and voice assistants. And for tracking emotions, the Effectiva's Emotional AI, a Boston-based company founded by researchers from MIT's Media Lab, and acquired by SmartEye, specializes in AI that reads emotions. Their technology analyses facial expressions to gauge people's emotional and cognitive states. And some of its applications are semi-autonomous cars. Effectiva's emotion reading technology is used in cars to monitor and improve driver behavior. Media and advertising. Their emotion tracking system helps advertisers and media creators test audience reactions to ads and programming. The technology, built on a dataset of over 7.6 million faces across 87 countries, is used by about 1/4 of the Fortune Global 500 to predict purchase intent, sales lift, and viral potential. By advancing common sense reasoning and emotion recognition, AI can more reliably interpret the nuances of human behavior and language. These improvements will enhance user interactions with chatbots and digital assistants and help businesses better understand and predict customer responses to their products and advertising. Okay, let us now move on to data component of the ideas framework. First, we will discuss about the challenges with data like the siloed data. Business data is often locked in legacy, on-premise systems, making it difficult for employees to integrate data from different departments. This siloing restricts information sharing and hinders comprehensive data analysis. And the next is about modernizing data foundations. Creating a robust data foundation involves breaking down these silos to unify data, optimally store it, and ensure it's easily accessible and analyzable with modern tools in the cloud. A strong data foundation means more data from diverse sources managed with AI support and disseminated across the organization. This approach allows companies to unlock their data's full potential for strategic insights. Let us now discuss about the case study of McDonald's transformation. Starting with the challenge, in 2018, the McDonald's faced fierce competition as its rivals harnessed online delivery to cut into its dominance in the fast food market. As a solution, McDonald's leaders partnered globally with Uber Eats to establish an online delivery system, which by 2019 had generated an additional $4 billion in annual sales. And the long-term strategy was for data-driven transformation, as McDonald's understood that its long-term success required a shift to becoming fully data-driven. They transformed their restaurants into large-scale data processors. Machine learning and mobile technology enabled personalized orders and delivery services. They used data analysis-supported predictive models that evaluated how external factors like weather and sports events would affect demand and the ability of restaurants to serve customers. And the real-time data insights helped design new products and initiatives that were well received upon launch. McDonald's transformation through data integration shows impressive financial results. Within 2 years, their strategic shift placed them among the top performers in the S&P 500. This achievement demonstrates that laying a strong data foundation and leveraging AI can yield substantial benefits. So, the McDonald's story exemplifies the critical importance of establishing a unified data foundation. By aligning data infrastructure with advanced AI and predictive analytics, businesses can respond swiftly to market changes, deliver personalized services, and stay ahead of their competition. So, building a modern data foundation to fully harness the value of big and small data through AI, organizations must establish a solid data infrastructure. This involves three key capabilities. First one is modern data engineering. Data flows in from multiple internal and external sources using batch processing, real-time mechanisms, and APIs. The data is consolidated into well-structured, reusable datasets suitable for various analytic purposes. The effective data engineering relies on reusable data ingestion and ETL, the extract, transform, and load frameworks that accommodate diverse data types. These frameworks incorporate data quality and standardization rules, enabling quick and scalable development of new data pipelines for analytical use cases and products in the cloud. The second is AI-assisted data governance. The AI-driven cloud tools help automatically cleanse, classify, and secure ingested data. This automation ensures improved data quality, veracity, and ethical management throughout the data lifecycle. Strong governance practices are crucial for protecting sensitive information, meeting regulatory standards, and maintaining organizational trust. And the third one is data democratization, where organizations must make data accessible across teams to maximize value. This approach requires establishing shared data literacy, tools, and standards for effective usage. The democratized data allows employees to leverage AI-driven insights for decision-making, improving productivity and innovation. A modern data foundation gets more data into more hands. It makes data accessible and easy to use in a timely manner, while enabling multiple ways to consume data, including self-service, AI, business intelligence, and data science. The latest cloud-based tools democratize data and empower more people across the enterprise to easily find and leverage data that's relevant to their specific business needs. Together, these three capabilities help companies overcome some of the most common barriers to value: data accessibility, data trustworthiness, data readiness, and data timeliness. They enable companies to blend data from big and small datasets together in real time, build agile reporting, and leverage AI to create broadly accessible customer, market, and operational insights that deliver meaningful business outcomes. In summary, a well-constructed modern data foundation, governed by AI-assisted tools, and democratized across the organization ensures that businesses can fully utilize the power of data analytics. This helps them stay competitive, respond to market changes more quickly, and create value for customers. With this we come to the end of this lecture, and for a quick recap of this lecture. We discussed the intelligence and data landscapes of the ideas framework. There are many shortcomings of deep learning-based AI. Machine intelligence is now being augmented with human intelligence. Humans have superior cognitive intelligence and machines excel in pattern recognition. We studied the implementation of smart robots augmented with human intelligence at OBETA helped them to increase reliability and speed. Three key capabilities are required to build a modern-day data foundation: modern data engineering, AI-assisted data governance, and data democratization. We hope that you have found this course informative and interesting. Please hit the like button and subscribe to our channel and stay tuned for our upcoming courses. Your support means a lot and motivates us to create more educational resources for you. Stay tuned for the next lecture, where we'll continue our journey through AI in marketing. Thank you for watching and see you again in our next lecture.